So this is my lesson for introduction of logs. Now you will have seen this in the classroom, and this is going to reinforce all the stuff that we saw in the classroom today. So here it says multiplication is a shortcut for addition, right? Instead of going 5 plus 5 plus 5, we can go, oh, well, 3 times 5, because there are 3 5s. So multiplication was made as a shortcut for addition. And exponents are a shortcut for multiplication, right? So instead of writing 4 times 4 times 4, mathematicians, we're lazy. We don't want to write all those 4s out, so we just go 4 to the third power. We made this new notation to deal with that shortcut. So logarithms are just a shortcut for exponents. It's a way to find the exponent. So why do we need logs? And this kind of explains why we need logs. So 2 squared, we know what that is. We get 4. 2 to the third power is 8. We know that. But 2 to what power is going to give me 6? What if I know my answer needs to be 6, and I want to know 2 to what power is going to give me 6? Well, that's where logs come in. Now, I think in class, normally I have students predict, okay, well, what do you think it's going to be? Maybe it's somewhere, you think it's, some people often say halfway between 2 and 3. They're like, well, I think 2.5, because you know halfway between 4 and 6, halfway between 4 and 6, so 2.5 would be good. All right, but it actually isn't 2.5. It's close to 2.5, but when we do log base 2 of 6 equals x, which is changing this into log form, we actually find the exponent would be 2.585. And you could plug that in. 2 to the power of 2.585. Why don't you try that real quick? See if we actually get 6. Now, I may have rounded this, so you might get something very, very close to 6. But, yeah. All right, so try that. Check it. I'm not lying. All right. Oh, right. Okay, let me change this really quickly. We are going to, oh, hold on a second. I can do this. Okay, that's better. Exponential form, Ms. Besh introduces this as ben, b to the e power equals n, which kind of makes sense. The base, b, to the exponent, e, equals some number. So b to the e power equals a number. So we call that ben, so for a shortcut, exponential form. And logarithmic form is log base b. So this same b, if we change it to log form, is going to be here. The base is here. Log base b of n equals e. So this whole chunk right here really is equal to an exponent. Notice the e. So in order to isolate that exponent, we can change it into log form and find out what that exponent is. All right, so the way that we read this is b to the e power is n. B to the e power is n. And it is very important to me that you know how to talk about this stuff. You need to be able to say it. Here, whenever you read this, I want you to read not log b, log base b. You need to say that word base. So log base b of n is e, or equals e. So log base b of n. So I need you to be saying this. So go ahead and write this down. This is very important. And then b. So really what we're asking ourselves when we're trying to figure this out is, well, b to some power is going to get me n. B to some exponent e gets me n. And we want to try and figure out what that is. All right. So we've got the formal or official definition of the log. The logarithm of y with base b is defined by this. Log base b of y is x if and only if b to the x power equals y. With b being greater than 0, right? So we're not having a negative base, just like our exponential functions. And y has to be greater than 0. So we're not talking about, let's see, what are we not talking about? So y has to be greater than 0. Because we've restricted b to being greater than 0, there's no way for us to get a negative number here if b is going to be positive. And b can't equal 1, and we've talked about that. If we had 1 to any power, it's just going to be a straight line. So that's not going to be an exponential function. So one skill you need is to rewrite from logarithmic form to exponential form. So if I give you this, go ahead and write that down. Log base 2 of 64 equals 6. I'd appreciate for you to, this is nice while you're at home, you can say it out loud. I want you to practice saying it. Log base 2 of 64 equals 6. All right, how I'm going to rewrite that is I'm going to, as I'm reading, I say log base 2. Well, I just identified my base by saying log base 2. That's my base. My base is 2. Log base 2. Oops. 2 to the e power, sorry, the base to the exponent power equals n. So I draw this little arrow. It kind of helps to start at the base. So 2 to the 6th power equals 64. And that's going to be my exponential form. So I start log base 2. So it's very important that we're saying base because it gives it away. 2 to the 6th power equals 64. And that is correct. We could plug it in our calculator and make sure. Raise 2 to the 6th power and you will get 64. All right, let's try this one. So log base 5 to the 0 power equals 1. All right, so we take our base is 5, to the 0 power equals 1. And we know that's true. Anything to the 0 power is 1. So if you want, you can draw your arrow. Log base 5 to the 0 power equals 1 to help you get from log form to exponential form. All right, so here are 6 problems I want you to try. I will do one more with you really quickly. So I read this. Log base 7 of 49 equals 2. Log base 7, here's my base, 7, to the 2nd power equals 49. And yeah, that should be a true statement. 7 squared is 49. That's a true statement. Okay, good. So I want you to hit pause right now. Try these problems and see if you get them. It's very important that you're practicing this as part of your homework. You need to pause and try them on your own before you check your answers. Okay. All right, so the answers are here. We got 10 to the 4th equals 10,000. 25 to the 1/2 power equals 5, right? Square root of 25. 9 to the 1st power is 9. 125 to the 1/3, so the cube root of 125 is 5. And 2 to the 5th is 32. All right, if you have questions or confusions about why any of those are the answers, please write down your questions right now so you can bring it up tomorrow in class. All right. Now this is without using a calculator, evaluate it. Well, there's something missing here that we had in the other ones that we don't have. So can you identify what's missing? Log base 3 of equals There's something missing here. So what I want you to actually do is write equals question mark. And we will have done this in class. So this won't be completely new to you, but we want to say, okay, log base 3. 3 to what power? To the question 3 to the question mark power equals 243. So I need to figure out 3 times 3 times 3 times 3. How many 3's am I multiplying together to get 243? So I can figure out my question mark. All right, so we could actually rewrite 243 as 3 to the 5th power. So we have 3 to the question mark power equals 3 to the 5th power. Well, what does the question mark equal? And there's this rule that says, well, if we have the same base and the two sides are equal, the exponents must be equal as well. So the question mark equals 5. So if I'm to evaluate this, here's another example of it. We just have 5. So 3 to the what power equals 243, x equals 5. All right? Here we have 1/2 to what power equals 32? Whoa, 1/2. How am I going to get a half to some power, question mark power, equals 32? Now this is a fraction. How do I get a fraction to make it into a whole number and not a fraction? Oh my goodness. Now we've talked about this before. Okay, let's see. A half to what power equals 30? I know that 2 to the 5th power, what if I took 1/2 to the 5th power? I would get 1 over 32. But that's not what I want. How can I get this to become that? Well, we have the tool already. When we raise it to a negative power, right, what's going to happen? That's going to flip. So if I raise 1/2 to the negative 5 power, this 1/2 becomes reciprocal. So this tells me change to reciprocal, and this says raise it to the 5th. So that would equal 32. So our exponent, or this, is equal to negative 5. All right. Let's try this one. 16 to what power equals 2? Now we have something starting off big. 16 to the question mark power, right? Put in a question mark. 16 to the what power equals 2. 16 to some power equals... Now we have to go from a big number to a little number. In order to do that, we're not going to be squaring it or cubing it or to the fourth rooting it or fourth to the raising it to the 4th power. We are, however, what if I square root 16? Would I get 2? Now, if I want a square root as a fraction, I would put 1/2. That would take the square root, but it's not equal to 4. So do I want the 3rd root? No, I actually want the 4th root. If I take the 4th root of 16, I will get 2. So my fraction, it's asking, well, what's this fraction? That fraction is 1/4, because I'm taking the 4th root of 16. All right, here, let's see. Just confirm that they agree. All right. So there's a couple more things we need to address, and that is the common log and the natural log. So common log is on your calculator, and natural log is also on your calculator, whereas log base 5 is not on your calculator. So common log is when you don't see any number here. It is implied that it's a 10. So if you don't see a number like on your calculator, the base is 10, so it's log base 10. So the log with base 10 is called the common log. Common log, and is denoted by just log of x. Now the logarithm with base e, so we know what e is, right? E is 2.718 approximately, and it's called the natural base, so this is called the natural log. When you have a log base e, we're talking about natural log. Now, a lot of people think this is in, but it's actually an L. Some people do like this, ln, kind of in cursive, the natural log of x. But why don't they put NL? I don't know. Natural log would make more sense. Maybe it's some Latin name. I don't know exactly. All right, but natural log is like backwards. Log natural. Log natural. Sing log natural. All right, so natural log is ln. ln of x. All right, so this is the last slide. I want you to rewrite these log expressions into exponential form and evaluate these expressions. So 2 to what power, you have to put your question mark, 2 to what power equals 64. All right, so watching the video was your homework, taking notes was your homework, but I also want you to do these 4 problems and these 4 problems here and come in tomorrow with your answers. All right, also come in with questions. All right, thank you guys. I will be checking this. Okay.